video, I'm going to explain about process state diagram. Sometimes it is also called as process state transition diagram. State diagram or state transition diagram. Okay, both are same. So, one of the important concept for the exam point of view, and as well as for not to understand the concepts in process management, in the entire process management, whatever the concepts we are studying, for that this is the basis. Okay, so but we know that what do you mean by process, right? What do you mean by process? The running program is called as a process, or program under execution is called. That means whenever our CPU start executing our program, so that program which is under executing by the CPU, we call it as a process. In simple words, we say a program is nothing but a process, is nothing but a running program. Running program. Now we know that what. So I told many times. See, we user always stored everything in what? Our secondary memory, that is hard disk. We are storing that program. Okay, assume I have stored some file. It may be some game, it may be some movie, it may be some a song, it may be some file, it may be some PDFs, whatever it may be. We'll call this one program. Now it's stored in the program. Okay, now whenever we want to execute that, generally what we will do, generally we will double click on it, right, in the Windows. So when we double click on that, whatever the program we return, so using some high level language, it has to get converted, okay, into the machine level language. That means many object files will be created, and all those object files are linked together to a single executable file. And this is my original program. Okay, this is my, well, called as a source program. Okay, our source program. Now our source program will get converted into a separate file called executable file. So I will call it as an exe file, executable file, and that exe file of our source program is also stored in our secondary memory. That means now this file is now ready to execute, but still it is in the secondary memory. But our processor CPU can take only the data or the instructions from main memory, that is our RAM. So what we need to do, somebody has to move this file from this secondary memory into the main memory, that is RAM. So that will be done by our operating system. Okay, in general. Now let us see what exactly in the operating system, because operating system is a huge collection of programs. Okay, so especially that one program is there, that program brings from the exe file from secondary memory to the RAM, that we discussed in the previous, that is called the loader program. Okay, loader will load our executable file into this one. Now whenever, okay, now once it draws into the main memory, and once it brought into the main memory, now this program is now ready to execute. That means now it came into the RAM and now it is waiting for CPU time. Now once CPU starts executing this instruction, now I can say this, our program is executing. Now it becomes what? Process. Okay, this we all know. Now during the life cycle of a program, so every process should be in any one of the 5 states. There are totally 5 states are there. Out of those 5 states, our program should be in any one of those 5 states. Okay, and now we know what you mean by process, a running program. So what do you mean by state? A state of a process is defined as the current activity performed by the process. That means currently our process is doing what activity, that will be defined as a state. Okay, so current status or current situation. So currently our process in what situation, that is called as a process state. Okay, that we are explaining in the terms of some diagram. Okay, now I told whenever we double click, when we start executing our program, so its exe file will be created. Now at that time I will say my process is newly created. Now it is in the state called new state. Okay, whenever our source program is converted into exe file, now that is newly created. Okay, but still it is in where? In the secondary memory. Okay, once it admits to what? Main memory, then I will call it as a what? process, then we call process. Still it is a program. Once it comes to a process, and now once it comes into the main memory, now it is ready to execute. So once from the secondary memory brought into this main memory, now this is in form of ready state. Now our process moves from which state to which state? It comes to from new state to what? Ready state when it was admits. That means when it is admitted to what? When it is admitted to the main memory. When we brought into the main memory, it is in the ready state. Means it is ready to execute. Now it is waiting for whom? Processor. So once processor comes and executes, till that's waiting for the processor type, CPU type. Why? Because while we are bringing this from secondary memory to the main memory, our CPU is not simply sitting idle. CPU is executing some other process. Okay, so there is not only one process in our main memory. Okay, there is not only one process in our main memory. There will be multiple programs. There may be multiple programs or processes are there in the main memory. All those are waiting for process. Assume, for example, now currently our CPU is executing this process. Our CPU is executing currently this process. Now all these processes are waiting for CPU time. Okay. Assume once our CPU completes this process, completes the execution of this task, now somebody has to select any one of these processes which are waiting for the CPU time. Because see, there are 4 processes are there. 1, 2, 3, 4 processes are there. Now somebody has to select. That means our operating system has to select after completing the one process which one to select the next one for execution. For that, so it is using one special program called, that is again system program, a part of the operating system, that is a scheduler. A scheduler is a special type of system program, part of the operating system, which will select which process has to be executed after one process completes. Okay, so that scheduler, okay, it will select. Once the scheduler will select, now currently the process is executing. This means process is there with the CPU is there with this process. Now it has to take CPU from this process and switches the CPU to this process, our process. So that will be done by another program called dispatcher. Now once our dispatcher transfers the processor from the currently running process to the next process, then we can say our process is in the executing state. Because once this processor is assigned to this, now it takes this first instruction and executes. Takes the next instruction and executes. Now I can say our process is in which state? Executing state. Or we can say instead of executing, so generally we use the term what? Running state. Running state. Running state. Okay. So this it comes from where? From ready state to what? Running state. When it will come to ready to running state? Whenever our scheduler select and dispatches the what? Scheduler dispatches the what? Our CPU to from one process to another process. Now our process from ready state becomes what? Now it is calculated. Now this program, now this is done. Okay, now this program is done, its execution is done. So now this is my process currently executing. So that we call running state. Now while my process is running, now that means running means what? CPU is executing its instructions. Now after some time, so our process needs some IO devices, because in every program, whichever the program you take, C++, Java, Python, .NET, whichever, we have to use some data transfer. That means sometimes we need to take the input from the input device, or we need to read some data from the memory, or we need to display the output on the monitor. That means we have to use some IO devices. So assume this is my program. Okay, assume this is my some program. Initially, these two are my computational statements, that means CPU has to execute. Assume the next statement is IO statement. For example, the third one is what? IO statement. That means now this statement requires input device or output device, but now since it requires input device or output device, it doesn't need what? CPU right now, because it executes this two. Now it wants some input or output device. So now it doesn't need CPU. So instead of making CPU, what we will do, we will assign CPU from this process to some other process which are in the ready queue. Okay. Now when you switch on this, now our process wants what? Our running process wants some IO device. Assume that IO device already busy with some other process. Now what it has to make? Now it has to wait until that IO devices becomes free. So from running state, it goes to which state? Waiting state. So now from ready state, it goes to what? Waiting state. When it goes to waiting state, whenever our running program requires some IO device or it is waiting for some event to occur. That means that, suppose assume it is waiting for some other program result. So it is depending, it's a cooperative process. So it is wants some of the output from another event. So whenever our running process requests IO device or it is waiting for some event to complete, then it doesn't need our CPU. So now instead of making CPU, we have assigned CPU to some other process. Now assume now our process is executing this one. Assume this is executed. Now this is stopped execution. Okay. At some point of time it stops. It executed right now. Now our process is waiting for what? IO device. So it goes to the waiting state. Okay. Assume after some time IO device becomes free and IO operations also completed. But that means this task is done. Now again it needs what? Our CPU time. That means now it is done. Once IO device are event is completed, now again our process requires what? CPU time. But already we assigned that CPU to some other process. Now again it is, everything is completed IO, it is in the main memory. That means it is ready again to execute. But it needs what? CPU time. So again it went to, from waiting state, it goes to what? Ready state. When it will move from waiting state to ready state? Whenever IO operation completes or some event occurred. Okay, so in both the case done, so then it will go from waiting state to ready state. That means now again my process is ready to execute, but it requires CPU time. So it is in the ready queue again. Now, so whenever our process is running, okay, let's take another case. Now whenever our process is running, some interrupt may occurs. The interrupt may be the hardware interrupt or the software interrupt. That is a trap. Okay, whatever. So once it comes, now interrupt occurs means, so now the process needs to execute some of the interrupt service routines. Now what happens? Our processor stops executing currently running process, attends that corresponding interrupt and goes to interrupt. Now it is what? It is not waiting for IO, but it is now again what? CPU, because once our process is running and it needs some interrupt occurs, now CPU has to attend what? That interrupt. Now CPU stops for time and goes to what? Interrupt. Now it goes means it doesn't have CPU. Again it wants CPU, means again it goes to what? Ready state only. So that means whenever interrupt occurs, okay. So whenever some interrupt occurs, the process goes from running state to ready state, indicating that again it is waiting for CPU time. So like that it keeps switching from one state to another state. It is the entire life cycle of the process. Okay. Once our running program completes its entire task, then it goes to what? Terminated state. Terminated state. Okay, so now it is going from which state? Always it goes from running state to what? Terminated states once it completes. Now this is your what? process state transition diagram. Okay, so now if you observe this diagram, our every process should be in any one of these states during its entire life cycle. Okay, so this lifespan of any process, it should be in any one of these five states. So new, ready, running, waiting, terminated. And at any point of time, any one process should be in the running time at a time. It should be in any one process should be in the running state. But multiple process may be in the waiting state, or multiple process are in the ready state, or multiple process may be in the new state in the secondary memory only. Okay, this is now summary. When the process will be in the new state, whenever executable file will be created and it is secondary memory, it will be in the new state. Whenever it draws into the main memory, so then we can say it is ready to execute and waiting for CPU. Suppose if any process is in the ready queue in the main memory, means it is waiting for only the CPU, it is having all the resources. Okay, it is having main memory spaces, some files it is having, some what IO devices having, everything is having, but it needs only CPU time. At that time only it will be in the ready state. Once it got CPU time, it goes to the running state. Running state means CPU is executing the instructions of that process. Okay, so that's what the running state. So now when it goes to the waiting state, whenever our processor's instructions need some IO operations, so go to the waiting state. Okay, waiting state, and that IO device is not free right now. It is already servicing some other process, so it has to wait for IO device becomes to free. Once IO devices becomes free, once it completes the task, again it comes to the ready state, waiting for the CPU time. So when running to ready state, it will comes. So whenever interrupt occurs, it may be a software interrupt or it may be hardware interrupt. At that time, processor stop executing the current process, attends the interrupt service routine, and again attend the interrupt service routine. So by that time, our running process is again waiting for the processor. Okay, now once our program completes its task, so it goes to the terminated state. Okay, these are the five states. See, in some textbooks, some people use different terminologies for these five states. As I said, running or executing something, but concept is same. So every process, any process should be in any one of these five processes. Again, summary is any one process should be in the running state at a time, and any number of processes may be in the waiting state or in the ready state. Okay, so hope you clear the concept of this process state diagram. If you have any questions, please write it in the comments. Thank you. Thanks for watching.